Hey guys, today we're starting Chapter 2 for FST, and Chapter 2 is called Functions and Models. Basically in Chapter 2 we're going to be doing an introduction to different types of functions. We're going to be talking about domain and range of different functions. We're going to talk about graphing functions, and we're just going to basically learn what are the characteristics of a function, what does it mean to be a function, and then we're going to take that and apply that to different real-world situations. So for section 1, this is called the language of functions. We're basically just going to be talking about what are these words meaning. Okay, so how can I take these words and interpret them into mathematical ideas? So a function is a set of ordered pairs x comma y in which each value of x is paired with exactly one value of y. So a correspondence between two sets A and B in which each element of A corresponds to exactly one element of B. So in other words, in order for something to be considered a function, for everything that you put into the function, you have to get exactly one thing out. So if you can't get anything out, then it's not a function, and if you get more than one thing out, then it's not a function. So you have to get exactly one thing out for everything that you put in. Okay, a domain is a set of all allowable substitutions for the independent variable. In other words, it's all the stuff that you can put into a function. So, I'll show you guys a little bit more using the function machine in just a minute. We've also got the range. That's a set of possible values for the dependent variable. In other words, it's the stuff that you get out of a function. Okay, so let's talk about the function machine real quick. What I like to do to determine whether something is a function or not is create what's called a function machine. Basically, I just made this up. And let's say my function is y equals 3x, okay? If I put something into that function machine, let's say I put a 2 into that function machine. Well, 2 would be part of my domain then, okay? Domain is anything that I can put into the function machine. Okay, what I get out of the function machine then would be 6, because if I plug that in here, 3 times 2 is 6, so that would come out of my function machine. If something is a function, that means that we can put it in the function machine because for everything that we put in, we only get one thing out. So in your function machine, if you put more than one thing in, if you put one thing in, you get more than one thing out, that would break your function machine and therefore it would not be a function. Also, we can think about the stuff that we put in as being our domain values and the stuff that we get out as being our range values. Okay, we also have the vertical line test, and this says that when you're drawing a vertical line through the graph of a function, it will intersect the graph in no more than one point. Okay, so if you have a function, you can check to make sure that something is a function using the vertical line test. Basically, you graph your function, and if you can put a vertical line and it passes through more than one point at any time, then it's not a function. Okay, so let's do some problems. The cost of renting a car is $150 down payment and 25 cents per mile. Write an equation for this situation. Well, first of all, I need to figure out my independent and dependent variable. So I have a down payment, I have 25 cents per mile, so that means my two variables are going to be cost and miles. So I'll just say C equals my cost and M equals my miles. In which case, I can say that my cost is going to be 150 plus 0.25 times the number of miles that I have. So my independent variable in this case would be the number of miles I have. Whereas my dependent variable would be the cost because that depends on the number of miles that I've driven. Okay, so what is the domain? In this case, I want to think about all the possible things that I could substitute in for my independent variable. My independent variable in this case is the number of miles. So what types of values could I plug in for a number of miles? Could I plug in negative values? Could I plug in 0? Could I plug in positive values? Okay, hopefully you realize that you can't have a negative number of miles, so what you would have here is m is greater than or equal to 0. Or another way you could write it is all real numbers that are positive and 0. Okay, the range, that's the stuff that you can get out of the function. In this case, it's talking about your dependent variable, which is cost. So what types of things could you get out of this function? Well, if you're only plugging in stuff that is greater than or equal to 0, that means that my lowest cost would be if I had 0 miles. And if I had 0 miles and I look at this function here, how much would that cost? Well, it would cost $150. So that means that the smallest amount that I could pay is $150, and I could pay anything greater than that. So my range is going to be that C is greater than or equal to 150. Okay, or you could say all real numbers greater than or equal to 150. Okay, so let's consider the equation y equals 2x squared plus 10. First of all, is this a function? Well, the easiest way to determine whether something is a function or not is to do the vertical line test. So I'm going to start by graphing this function. So if I go up 10, basically my function is going to look like this. Okay? So if I were to put a vertical line in here, okay, put a vertical line, is there any point where my vertical line will cross through more than one point? The answer is no. Therefore, this is a function. Okay, what is the domain of this function? What types of values could you plug in for x? Hopefully you realize you could plug in anything for x, so I'm just going to say all real numbers. What is the range? So what types of things can you get out of this function? Well, looking at the graph here, I know that my y values are going to be 10 and everything above 10. So I can say y is greater than or equal to 10. We also have what's called function notation. This is basically just a different way to write functions so that it's not y equals. So when you have a function, you can refer to a function as f of x, or g of x, or h of x. Okay, that's called function notation. So f with the parentheses around x is read f of x. It's not f times x. Okay, so let's consider f of x equals 5x squared. If I want to find f of 4, basically what that's asking me to do is plug 4 in for my x value. So I'm replacing my x value with 4, therefore that's what I'm going to do in my equation. So I'd have 5 times 4 squared, which is 5 times 16, which is 80. So f of 4 equals 80. Okay, for my next one, I have g of x equals 13 times the quantity x minus 3. And I want to find g of 10. So again, I'm going to replace my x value with 10. So I'll have 13 times 10 minus 3. So that's going to be 13 times 7, which is 91. My last one here, I have p of y equals x squared plus 1 over x. And I want to find p of 6. So I'm going to replace my y value with 6. So I get 6. Ooh, this should say x. So I'm going to replace my x value with 6. So this will be 6 squared plus 1 over 6. So that's 36 plus 1 over 6, which I can just leave as 36 and 1/6. All right, that is everything for section 1.